Okay, we are looking at lesson 8.2. This is going to be the first half. So today on this one, we are just going to be looking at an arithmetic sequence, and then in part 2 is when we'll do the arithmetic series. Arithmetic sequence, so this is on page 223 in your journal. So for an arithmetic sequence is simply a sequence where anytime you are adding, and that's your key word, when you add to get the next term. So for example, if I had a pattern like 3, 6, 9, 12, so on and so on, and I said, describe this pattern, you would say, well, I am adding 3 every time to get the next term. So anytime you are adding, that tells you it's an arithmetic sequence. The number that is being added is called the common difference. So for this example, we would say the common difference is 3, right? That's the number that's being added every time to get the next term. There are some that are a little challenging to figure out. This one is obviously really easy to see that I'm adding 3. When in doubt, a common difference can always be found by doing any term minus the previous term. So I could do 6 minus 3 to get it. I could do 9 minus 6 to get it. I could do 12 minus 9 to get it. I could do any term minus the previous term. So I just say second term minus the first term. All right, so if I remember it's stuck, like maybe these are fractions or decimals or negatives, whatever, and if you're not sure, just do any term minus the previous term, and you'll get your common difference. So the one formula you're going to be using for this is going to be this guy. So this is the formula we're going to use in part 1. When we do part 2 of the video, we're going to be using this formula. So for today, this is our focus. So everything is going to be plugged into formulas today, just like this one. So a couple things you got to know about this. A of 1 is the first term of the sequence. N is the term number. So if I said the 20th term, you would put a 20 right there. The D is your common difference. Remember, that's the number that's being added every time to get the next term in the sequence. Super, super important on this one is the connection between this and this. This is the number of a term, and this is the value of that term. So if I had let's just say I'm going to go back to that pattern that we were looking at up above. 3, 6, 9, 12, 15. So you guys can see on this one that the fourth term is 12. So my fourth term is 12. That means when n equals 4, the value of that term is 12, right? And so the 12 would go right here for this guy, and the 4 would go right here for this guy. So really important connection between those two that you got to get out of this. So anyway, let me take you to the problems of the day. So just turn on the page to 224. And let me go through these nice and quick for you. I'm going to go through really quick because you can always pause and slow down this video if you need things to slow down. So I'm going to go through fairly quick, just knowing that you guys can pause this video at any time. So first few questions are just going to ask you, is this an arithmetic sequence? In other words, are you adding the same value every time to get the next term? Right? You can see on this one's definitely not, because it starts by adding 3 plus 3 plus 5 plus 5. So it's not adding the same number every time. So we would say there is no common difference. Right? Key word there is common. Right? It's got to have the same number that's being added every time to get the next term. If you take a look at this one, you can see that this one is going down 3 every time. So one thing to keep in mind, if it's going down 3, that just means your common difference is negative 3. All right, so we would say yes, that is arithmetic, because the common difference is negative 3. So this is when they say explain your reasoning, this would work as far as your explanation goes, just to say it has a common difference. Let me take you down to this next part here. So when they say write the rule, all this comes back to the formula for the day, which is this one that we were looking at on the previous page. So this is our formula for the day. Writing the rule, it's really simple. When they say the nth term, that just means they want you to leave n as n, because they want this to apply to any given term. It doesn't have to be a specific one. All we have to plug in for is the first term and the common difference. So if we were going to say for this one, you can see that my first term is 3, and my common difference is 6, because it's adding 6 every time. So all I have to do to write my rule is plug in a 6 for my first term, 3 for my first term. We leave n as n, and we're putting in 6 for the common difference. This works as a rule, but typically, like when you go to check your answers, they're going to simplify that. So they're going to distribute the 6 right here. And then if I combine like terms, I can get it to look like this. And so this is typically the way you want to write the rule. When you go to check answers, that's what you're going to see. Is going to look something like that. Let's try it for another one. Let's try it one with, it looks a little uglier. Something like this. See if we can do it. So you're welcome to work ahead of me on this. It's a great place to pause the video and give it a try on your own. So here's our formula. So again, all I have to plug in for is the first term, which is my 0.7. We leave n as n, but I do need to plug in something for my common difference. All right, and so remember on these guys, if you couldn't tell what the common difference was, you can take any term minus the previous term to figure it out. If I did 0.2 minus 0.7, then negative 0.5 would be my common difference. And so to finish it off, all you'd have to do is distribute the negative 0.5, combine like terms, and you have your rule. So the one extra step they're asking of us on this one is to then find the 20th term. All right, so a of 20 means the 20th term. So all I have to do is plug in a 20 for my n. So if I put a 20 right there, I would say 6 times 20 minus 3. And whatever that answer is, it would be your 20th term. Right? So we would say a of 20 equals 117. So we could do the same thing on this one. Again, you would want to simplify this first. So if you distribute and then combine like terms, then the simplified rule is going to say 1.2 minus 0.5 n, which you're welcome to switch the order on that. You could write it as negative 0.5 n plus 1.2. If you want to switch those around, that would be fine. Anyway, that's our rule. So now if I wanted to find the 20th term, I would just put a 20 right there. So if I did 1.2 minus 0.5 times 20, that would tell me that my 20th term is negative 8.8. All right, I'm going to flip this over. Corner number 9. We are not graphing these, by the way, so if you get any in the homework that asks you to graph, you don't have to graph. We're not graphing these. So anyway, on this one, they're telling me that the 12th term is negative 13. So this is what I was talking about before. They're telling me that the 12th term is negative 13. So in other words, when n is 12, the value is negative 13. All right, so really important that you understand what those go in for within our formula here. Okay, so if I have, this is my formula, same one. They're telling me that n is 12, right? That's the term number that goes in right here. And the value is negative 13. So when I go to write the rule, keep in mind on these guys, all I need for the rule is my first term and my common difference. Well, I know the common difference is -2. But in this problem, they didn't tell me what the first term was. So instead, they gave me this information that I have to use to figure out what the first term is. So again, I know that a of n is -13 when n is 12. And they told me right here that my common difference is -2. So again, all I'm doing is plugging into a formula. It's the same formula every time. I'm just taking the information that they gave me, putting it into the formula, and that's it. So nothing too fancy here, just plugging numbers into a formula. All I have to do is get this guy by itself, and I will know my first term. So let me do that real quick. Right here I'm looking at 11 times -2. So if I add the 22 over to the other side, then I know that my first term is 9. So I know my first term, I know my common difference. Those are the two things you need to write a rule. So my general rule says my first term is 9, and my common difference is -2. So this is good for the rule. Again, you could distribute this and then combine like terms. If you want to write it in a bit of a simpler version, then that's always doable. If you did do that, for those of you who will do that, then you would say maybe -2n plus 11, or you could say 11 minus 2n, same thing. All right, let me go down to this one. So for this one, we're actually going to write a system of equations to solve. So I still want to write the rule, which means I still need to know the first term and the common difference, just like I did in all the other ones. But in this case, they didn't tell me either one. I don't know the first term or the common difference, so I got to solve for both. So for this one, again, remember what they're telling you right here. They're telling you that when n is 8, the value is 59. So 59 goes in for, I'm going to write it. It's always nice to be able to look at the formula. So my a of n is 59 when n is 8. So there's our first equation. In the second equation, I know that when n is 13, my value is 99. So I have a value of 99 when n is 13. So those are my two equations, and we're going to do a little solving of a system of equations here. You can clean this up. This would just be 7d, and this would be 12d. In solving a system, remember you have things like substitution, elimination, things like that. Elimination works like this. You guys see those are the same. So all I have to do is subtract. So this is my elimination process that you guys learned a long time ago. I'm just subtracting everything straight down. So 59 minus 99 is -40. A1 minus A1 is nothing. Those guys cancel. Right here I have 7d minus 12d, which is -5d. And so if I divide this over to the other side, I can see that my common difference is 8. And all I need to come up with now is my first term. So remember, once you know that d is 8, I can just plug that back into a previous equation in order to figure out this guy. So I'm going to take my 8, put it right there for d. And now I can solve this equation to figure out what my first term was. So if I did 7 times 8, I got 56. Subtract that over, and I should be looking at 3 for my first term. Once you know those two guys, now you can write your rule. Because remember, the rule is I just put in the first term and the common difference whenever I'm writing a rule. So I'm just going to say that a of n, I put in 3 for my first term. We leave n as n when we write a rule. Plug in 8 for my common difference, and I have my rule. So, and again, I can simplify this. You could distribute the 8, combine like terms, and simplify it one more time. All right, here we go. So let me give you one last example. I'm actually going to back up to page 222 for this one. Go to the very bottom of 222, and let me show you this one. Oh wait, I don't need to show that in this video.